Okay, welcome to lesson 5. This is learning target 4. It's all about what a z-score is and calculating average, standard deviation, and z-scores. So I wanted to demonstrate how we'd actually calculate standard deviation and average. But we're not actually going to have to worry about this for a test. We'll do this more in the culminating assignment, actually calculating standard deviation. And there is a way to do it by hand, so I'm going to demonstrate how to do it by hand just so that students get exposed to that. But we also want to show how quick technology is with this, because in the real world that's what we would do. We just really have to understand what a standard deviation is. We'll focus more on that in the last unit in statistics, but we want to kind of just show what a z-score is. So it comes up here. Okay. So a little warm up for you. So the question is, if 16% of data is greater than 200, what might be the mean and the standard deviation? And so a question like this is very open-ended. We could say the average is almost anything. And so we could say since the data 16% has to be greater than 200, this really goes back to the lesson before on the shape of the normal curve. So if you want to think about that, you can come up with a mean and a standard deviation that would work. So I would actually notice that 16% is that interval that's the complement, it's half of 32. The complement is 68. And so you have to look at one standard deviation. So the z-score of 1 would actually have to be at 200. And then if you kind of think about the shape of the curve, and I'm just kind of drawing it with the mouse here, but at the shape of the curve, in the middle we could have the average. So say our average is 100, or no, that's probably not a good example. Say our average is 180, and if our standard deviation was 20, then that means that 68% of the data would lie between 160 and 200, and 16% would be greater. So the question is, the learning target is, how do you calculate mean and standard deviation? How do they relate to z-scores? What you're going to see on the quiz and the test is really just that question of what a z-score is, and what is it based on the average and standard deviation. So remember definitions like the mean is the average of a set of data. This is calculated by adding all the numbers, dividing by the number of points. Standard deviation is the distance a typical data point lies from the average. We'll continue to look at standard deviation throughout the rest of the course. It's calculated as an average distance. We're going to actually see the formula for that and why it gives weight to more points away from the mean, farther away from the mean. And a z-score is the number of standard deviations, so it kind of puts the two together, and it says how many standard deviations you are above and below the average. Formula for z-score is, again, I guess we can't remember if we've actually gone through this yet, so I just don't remember if it was in the last lesson. The average, so we take a typical point, subtract it from the average, and divide it by the standard deviation. We will use this formula through the rest of the unit, and more so in the next unit, or in the next learning target. Formula for the average, you add them all up. That's what the summation sign means. Add up all the x values, or all the numbers that you have, divide by the number you have. And this is the formula for standard deviation. This is a new thing. What this is saying is add up all the differences. So if you take the difference that each point is from the average, so you could have a point very far away from the average, you have a higher distance, and you take the square of those. So the square of the differences. So if you're far away from the average, when you square it, that's actually a bigger number. If you're really close to the average, when you square it, it's a small number. It's a very small impact. And then we divide it by n-1. So it's kind of like the average squares. It's just the n-1 is a little correction for the sample of the data. Most of the time we actually use a sample. It's rare that we can actually get all of the data points, but if we were looking for standard deviation in a class, we wouldn't actually do this correction of n-1. We would just do n, and that's the population. But a sample standard deviation is calculated this way, and mostly we look at samples. Okay, and then we take the square root really to kind of offset that squaring idea. except like you still do get a lot more weight from the ones that are further from the average. So when we say like it's basically like an average distance, what this is basically like an average of the squares, but then we take the square root to kind of cancel that out. So that's one way to think about it. We'll calculate each of these with technology. With a spreadsheet, you can just type equals average and highlight the cells. In the stats unit, we'll look at fathom. And standard deviation can be calculated by equals STDV and just highlight the cells. And so I want to show that now. Note, you will not need to calculate standard deviation using a long method. We're going to get a computer to do that for you. However, you do need to solve for the mean, the z-score, or standard deviation using a formula. So if any one of these things was unknown, like we would want to figure out what it is. So if you knew the z-score and the point and the standard deviation, you need to actually find the average. If you knew the average and the standard deviation, but you didn't know the point, but you knew where the z-score was, you would need to find that point. So we'll need to be able to like do the algebraic manipulation of this formula. But we won't actually have to calculate standard deviation by hand. Not even in the stats unit do I make people do that. I know some teachers do make them do it, and they feel that there's value in going through the calculation, and that's exactly what we're going to do right now. So like just note that like we don't actually have to do this. Like I just want to kind of expose this to you. I've already got this kind of set up a little bit, and so I want to show you. I'm just going to delete these guys and show you how we're actually going to calculate this. Okay, so I'm going to delete all of this stuff so that you can actually see what we're going to do here. Okay, so we have landing zone position of an airplane, so it's just a collection of 40 pieces of data. So that's important that we know that there's 40. You don't actually have to count them yourself. Like if you just highlight them, you can just drag. Just be careful when you're dragging. Like you don't want to grab the side. You have to click right in the middle to highlight. Personally, like with Excel, I like to hold Shift down and then just use the arrow keys. A couple things happen when you highlight down the bottom right corner that like they give you. I don't know why they're telling me that. They give you the sum. They give you the average, the min, the max, the count, and the number of numbers that you have. Yes, USB not recommended. I get it. Go away. So you do get a little bit just by highlighting them, but we're going to look at using some of these formulas. So set up like the data again, a little bit over here, and I want to look at taking x minus x bar. So like we're actually going to first calculate the average. And so the way we calculate the average is we just actually type, I'm going to type it again, equals average. That's mean. Excel doesn't use the word mean, they use average. You can highlight all the cells that you want to do. You can type in E2 to E41, but it's just easier to highlight cells. You can hit enter and you get 14.63. So what we need to do is find out each length from the average. So equals 10.6. So whenever we want to do a formula, we have to press equals, click the number, and we're going to subtract the average. And so I'm going to go down and find the average. It's just easier to use the arrows, and hit enter. So that is your first difference from the average. Now the problem with pulling this down is actually that E42 is going to actually keep going down as well, the E43, and that's sort of a problem. So Excel built in this little thing that if you press F4 on the reference to E42, it actually like locks, it puts dollar signs around the E and the 42 and it locks it in place. And so that way, like it's called an absolute reference. And so if we just highlight, now if we drag it down, that's a little bit slow. That's why it's jumpy. So now if we drag it down, it'll take all the differences and the E42 gets locked in, but like the X values go down. Now what we're going to do is we're going to square all of those. So what we want the exponent, it's the 6, press 2, enter, So square root of 4 is 16. That makes sense. Drag that down. Again, the computer's sort of bogged down. I think I have too much stuff open. Okay, and so you get all these averages. Now, if you sum them up, so equals sum, you can count them. So just add up all the square differences. You get 414. And then it says divide those by n minus 1. The formula says divide it by n minus 1. So we divide it by 39. And then we do the square root of that. SQRT bracket square root 3.2589. So I actually had the standard deviation calculated already. It's 3.5289. And the way we do that, and so like I only want to expose this to you once. Like that's how we actually do it long by hand. I mean, I could get you to do it for like 5 on a test, but I really don't want to do that. And then actually after you get the answer, the much easier way to do it is just kind of like we did the average. Instead of adding them up and dividing, we just actually type in equals STDEV, and we get the exact same thing. And so that'll give us the standard deviation. So that's why I say like technology can do this for us. I'm much more interested in you knowing what that means. Like that's the typical distance that that a point lies from the average. And so what we say, if we know the shape of a normal curve, although this isn't necessarily normally distributed, and probably it isn't, but a normal distribution gives us a rough idea of what standard deviation means. If the average is 14.63, I can say that somewhere like 68% of the data is roughly between like 11.4 and 17.9. So that's actually a fair assessment to say. Like 68% of the data is between 11.4 and 17.9. And like if you actually look at the data, that's actually not a problematic thing to say, or not a unfair thing to say. So that gives you an idea of what standard deviation does and how we calculate it. So back to the slideshow. Again, I don't want you to worry too much about calculating that by hand. The big thing is just that you can follow along with that, and we know that we can get technology to do it for us. So like when you're assessed on this, I really just wanted you to know, like I want to expose this to you, and I want you to know like what a z-score is. And so a z-score, now that we know how to do the standard deviation, just tells us like how many standard deviations we are above the average. So here's some discussion questions. A data point lies very far from the average. Give 2 different examples of numbers that could be the average, standard deviation, and z-score. And so you could say like, well, if the average is 100, standard deviation is 10, like a z-score could be like 6. Or sorry, that's probably pretty high. Like a z-score could be like 2.5. That would be really high from the average. Negative 2.5, that would be lower than the average. If you had the z-score and the average, how could you calculate standard deviation? Give an example where you have to use a calculator and where you don't have to use a calculator. You actually also need a point too. I should have said that. So you don't have to use a calculator if the point is on like a z-score. So if the standard deviation was a whole number. So if you had a z-score of 2 and the average was say 5, then like the point could be 7, and standard deviation would be 2 or 1 in that case. If you had a z-score of 1, like that you don't actually need a calculator for. If you had a z-score of like 1.3 and you had a mean of 2.5 and you wanted to find out, well, if the point then would maybe be like above the average because the z-score is 2.3, you maybe set a point above and then kind of figure out, okay, I've got these unknowns, I've got this formula, like now I've got to solve for it. For a given average, give an example of a data point that would have a very large impact on the standard deviation and one that's very small. And so the idea here is just like it's very close to the average if it doesn't have a big impact, and because that's where you have 0. Standard deviation is a measure of consistency. So if you have a point that's way above the average or way below, that's going to affect the standard deviation. There's some questions to actually work through, and so there's some spreadsheet questions for you to practice. And I would just go into Google Cloud or Google Spreadsheets and practice that. You can use Excel if you have Excel, and so those are some practice questions for you.